a 0.25 kilogram box on a table is pushed against a spring so that it compresses 25 centimeters. The spring has a spring constant of 100 newtons per meter. The box is released and the spring pushes it forward. What is the maximum speed of the box? Well, this is a very straightforward energy problem. The first thing we should do is think about what objects are involved so we can make sure we understand all the forces involved here. So let's start with, we've got the box, the spring, the table, and the earth. There's a force of gravity. The table, of course, would exert a normal force, and the spring would exert a spring force. And so our free body diagram of the box would look like this. Here's our box. It's going to experience the force from the spring forward, the weight down, the normal force would be up, and the box is moving this way. Well, let's run through our 5 questions, which is a strategy for all these energy problems. 1, what is the system? Well, the system would be the box and the earth and the spring, and the table would be outside the system. All right. Number 2, do we think there's going to be a speed change? Well, yes, because initially the box is not moving, but eventually the box will be. So we have a definite speed change. Is there a height change involved? No. Is there a spring involved? Yes. And is there an outside object doing work on the box? And the answer would be no. The normal force does not do work on the box because it's perpendicular to the movement. So we end up with this formula here. A change in kinetic energy plus the change in potential due to the spring would be 0. So this is often referred to as a conservation of mechanical energy problem because no energy is actually going to enter or leave the system. So now we have Kf minus Ki plus the final spring energy minus the initial spring energy is equal to 0. Well, initially the box was not moving, so that would be 0. And at the end of the problem, it's not touching the spring, so there's no potential energy due to the spring at the end. So this reduces to the final kinetic energy minus the initial spring potential energy is 0. So this is a problem where you could envision it as simply being the potential energy of this due to the spring becomes the kinetic energy of the box. So now we just simply plug in. And obviously we can do a little simplifying here. And 25 centimeters is 0.25 meters squared. And mathematically, I see that just coincidentally that goes away. So Vf squared is 1/4 or 25. So the final velocity is 5 meters per second.